In this video, we're going to be going over 3 separate proofs involving congruent triangles. So let's go over the first one. This is number 5. Okay. I'm going to go ahead and draw the diagram real quick so I can use it in the explanation. Okay, so that's a D, A, B, E, and C. And then this is angle 3, angle 4, 1, 2, and that's it for the angles and the letters. I got all of them? Yes, okay. So I'm going to go ahead and mark the given information using a pencil. And the first thing that we're given is that angle 3 is congruent to angle 1. So I'm going to go ahead and mark that right here. So angle 3 and angle 1 are congruent. We also have that angle 4 and angle 2 are congruent, so that's over here. I'm going to go ahead and mark that using 2 little tick marks. Same thing on this side, 2 little tick marks, okay. We also know that angle DAC is congruent to angle 3. So DAC is this angle, right, this one right here, DAC. So I'm going to go ahead and mark this with one tick mark, okay. What else do we have? BAC is congruent to 1. So that would be this, BAC, so we're talking about this angle. This one is congruent to 1. Okay. And we have that segment AD is congruent to segment AB. So AD, which is this one up here, is congruent to segment AB, which is that one. Okay, so we have marked all the given information in the diagram. We want to prove that triangle CAD is congruent to triangle CAB. So the first thing that we're going to do is go ahead and I'm not going to write out the givens because we already know that first step. So I'm just going to make a line and I'm going to put given. And this represents all of the given statements. So I don't have to copy them all over again. And then these are the statements and reasons. Okay. Alright, so looking at the given information, looking at the given information and the statement we want to prove, you see we want to show that triangle CAD, meaning this triangle right here, is congruent to CAB, which is the triangle down here. So you want to show that the two triangles are congruent. At some point in the proof, we're going to need to use one of our either triangle congruence postulates or theorems. So remember, we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So we just want to try and figure out, okay, which one are we going to need to use in order to show that the two triangles are congruent. Well, looking at the given information in the diagram, we can kind of formulate a strategy. So it looks like, based on this information, we can show that this side, AC, is the same using the reflexive property to itself. So we would have this side from both triangles congruent. Then we would have, let's see, so we've got one side, then we have an angle right here. So that's an angle from triangle ADC congruent to an angle from triangle ABC. So we've got that information. And then we can probably use, see what else could we get here? We could use this as well. So the angle on the top, right, which for the triangle ADC, that would be angle 3 plus angle 4. That angle is congruent to angle 1 plus angle 2. So then if we have this angle congruent to this angle congruent to this angle, and this side congruent to itself, then we can use angle, angle, side. So that seems like a good strategy to use here. So let's go ahead and start trying to prove the individual statements. Okay. So we'll go ahead and get started with. So we're okay with angle CAB and DAC. We already know that those are congruent. We can start by showing 3 and 4 is congruent to 1 and 2. So let's go ahead and do that. So I'm going to go ahead and write it like this. I'm going to say measure of angle ADC. You can see that, and it's kind of small. Measure of angle ADC is equal to measure of angle 3 plus measure of angle 4. Alright, so we're just saying this big angle is equal to the sum of the two parts. The whole is equal to the sum of its parts, right? That is the angle addition postulate. So I'm going to write that here. Angle add pos. Okay. Now we're going to do the same thing in one line to get the bottom one as well. So let's go ahead and do the same thing for the bottom one. So measure of angle ABC is equal to measure of angle 1 plus measure of angle 2. And of course it's by the same reasoning. So I'm going to go ahead and divide the paper like that. Okay. And the next thing that we're going to do is we're going to go ahead and somehow show that these two are congruent to each other. So we can go ahead and use the given information that we have, and I'm going to go ahead and write that right here. So I'm going to write measure of angle 3 is equal to measure of angle 1, measure of angle 4 is equal to measure of angle 2. What else do we have? Do we need to use, let me see, DAC, DAC. No, we don't have to use DAC. Okay, well, we can stop there. All right. Okay. So both of these we knew from our given and the definition of congruent angles. Congruent angles. Okay. Let's see. So now we have that. So we can go ahead and use the substitution property at some point. So it looks like we'll go ahead and use it here. So you see how measure of angle 3 is equal to measure of angle 1, and measure of angle 4 is equal to measure of angle 2. So I can go ahead and plug that in, and I'm going to do it in one step. You can ask your teacher if he'll let you do this all in one step, or if you have to do it in 2 separate steps. But I'm going to go straight to plugging in measure of angle 1 in for 3 in the first equation that we have here, plus, and then measure of angle 2. Okay, I'm going to go straight to that statement. And this we got from the substitution property. Okay, fair enough. So now that we have that, we can use the substitution property again. This time, we're going to plug in measure of angle ADC for the expression measure of angle 1 plus measure of angle 2 into the second equation. So we're going to go ahead and write that as measure of angle ABC is equal to measure of angle ADC. So that's another substitution property. Okay. Now we can use a definition of congruence to show that angle ABC is congruent to angle ADC. So here we use the definition of congruent angles. Congruent angles, okay. Alright, so now we know that angle DAC is congruent to BAC from the given, and we have just shown that ADC is congruent to ABC. Now we just have to make the argument, or the claim at least, not the argument, but that AC is congruent to itself. So we're going to write this as segment AC is congruent to segment AC, and our justification for that is the reflexive property of congruence. Okay, so I'll just shorten it there. So now we have this side, oh, sorry, you can't see that picture. Okay, so we have this side, this angle, and then this angle here. So now we can finally claim that triangle CAD is congruent to triangle CAB, and the reason would be angle side. Okay, so that's how that one works. It's a pretty nice proof there. Let me go ahead and divide the paper. I'm going to go ahead and fit the next one underneath here. Oops, phone turned off. Alright, so the next one, let me draw the diagram first, and I'm going to use this blue pen for that. Okay. You have a triangle like that. Okay, we have angle 1 here. We have angle 2 on this side. Point E, and then some midpoint G. And this is H. This is F. Okay, anything else on here that I missed? 1, 2. Yeah, there's no line there. You had put the, okay, got it. Alright, so that's all the information on the diagram. And we're given that G is the midpoint of FH. So I'm going to use the pencil to kind of write down some information that we can get from that. That's that H, if G is the midpoint of FH, then this is congruent to that, okay, by the definition of the midpoint. And what else do we know? EF is congruent to EH. So this side over here is congruent to that side. Okay. All right. And we want to show that this angle here is congruent to the angle outside on the other side. Okay. And let me see one thing on the last problem real quick. Hold on. Okay. So I'm going to go ahead and draw out the statement, the proof statements here. So we got that. Alright, so for this particular proof, we're going to have to use something called a perpendicular bisector. So one thing that's important about this diagram when you're looking at it is that point E is equidistant from both H and F. So you see how F is on this side and it's approximately, this distance, right? Which is the exact same distance from H on the other side. So what this means is that point E lies on what you call the perpendicular bisector, right here. So that's a 90-degree angle. So at some point in the argument, we're going to have to use that information. So I'm going to go ahead and start it off with statements. So we already have our given. I'll go ahead and just write given and then put a line so you know what to write there. Okay. So the first thing that we're going to say is that HG equals, so HG equals GF. And how do we know that? That is the definition of the midpoint. Okay. Then we can use the definition of congruent segments to say that HG, segment HG, is congruent to segment GF. That's just definition of congruent segments. Okay. So the next thing is we have given information that E is equidistant from H and from F. So at this point, we know that E lies on the perpendicular bisector. So at some point, we can say EG is a perpendicular bisector to HF. There are different ways of writing this. There are usually 3 or 4 different ways that you can write this. So you can just verify with the notes just to make sure that this is the proper format they want you to use. So this is the most common way of writing it. So EG is a perpendicular bisector to HF. So it's saying that this is cutting this into 2 parts and it's a 90-degree angle there. Now how do we know that? We use the converse of the perpendicular bisector theorem. So I'll just shorten that, perp bisector theorem. Okay. So the reason why that's important is because we have we have shown that these are 2 small right triangles, and guess what? They are congruent. So now let's go ahead and make that claim. So how do we know they're congruent? So now we're going to say triangle GHE is congruent to triangle GFE. Okay, and how did I know that? Well, we have that HG is congruent to GF, we know that already, and we have given information that HE is congruent to EF, and we also know that HGE and EGF are both 90-degree angles. So at this point, we'll know that these are 2 congruent right triangles, and we know that using the hypotenuse leg theorem. So I'll put here HL for that. Okay. So now what do we do? Well, we can we can claim here that EHG, right, this one, is congruent. So this angle is congruent to the angle on the other side, GFE, by CPCTC. So now that we know that the 2 triangles are congruent, then we know that their corresponding parts are congruent. So we can go ahead and use that. So I'm going to say angle EHG is congruent to angle GFE. And then the reason for that is corresponding parts of congruent triangles are congruent, colloquially known as CPCTC. Okay, so we got that. Okay, so just a little bit more, and then we'll be finished with this proof. So what we need to do next is make a statement involving 180 degrees. Since angle 1 and EHG are a linear pair, then their sum is 180 degrees. So we can say right here angle 1 and angle EHG form a linear pair. And then we can say the same exact thing for angle 2 and angle EFG. So these also form a linear pair. I'll just shorten it, linear pair, for the sake of time. So how do we know that? We can say definition of linear pair. Okay, I'll shorten that here. All right. So now that we know that, then we know that the measure of angle 1, or you can, if you don't want to skip the step, we can go, let's go step by step and not skip anything. So since they form a linear pair, then we know angle 1 and angle EHG are supplementary. So I'll put SUPP. We also know that angle 2 and angle EFG are supplementary. Okay. And that's from linear pair theorem. All right, so we got that. And then the next thing we're going to do is actually write the equations here. So measure of angle 1 plus measure of angle EHG equals 180. And then we have measure of angle 2 plus measure of angle EFG is equal to 180. That's definition of supplementary angles, so just SPP. Okay, we got that. And then one more line in the argument, and that is that we can go ahead and use the subtraction property, can't we? Actually, we should use the substitution property first. Let's do that. So we already know that, where did we get that? EHG is congruent to EFG. We already know that by CPCTC. So that means that measure of angle EHG equals measure of angle EFG. And that's definition of congruent angles. So we're almost done here. So the next thing we need to do is use our substitution property. So I'm going to write measure of angle 1 plus measure of angle EHG equals measure of angle 2 plus measure of angle EFG. Okay, so that's substitution. Then we do substitution again. This time we're plugging in EHG for EFG. So we're going to get measure, here, let me split this here, hold on. So now we get measure of angle 1 plus measure of angle EHG is equal to measure of angle 2 plus measure of angle EHG. Notice I wrote the same thing twice. That's because I'm using the substitution property. Then I use the reflexive property. So we know that measure of angle EHG is equal to itself. So that's reflexive. And then finally, I can use the subtraction property to get measure of angle 1 is equal to measure of angle 2. So that is subtraction. Should have written smaller. And then let's see, do they want us to show that they're congruent? Yes, so we need one last line. So the very, very, very last statement is going to be angle 1 is congruent to angle 2. And the reason for that is definition of congruent angles. All right, so that completes that proof. All right, and then finally the third one. This paper doesn't. Okay. So the third one should be shorter. So we have a triangle. Oh my god, that's a terrible picture, sorry. Let me fix the picture. It should be more like that. So it looks like that. Then we have a line segment like that, and then another one like that. And then this is point A, point B, point C, point D. And then we have point E at the top. And I'm going to go ahead and draw in the given information using the pencil. So we have angle AEC. So where's that? AEC. So I'm going to go ahead and make kind of like an arc like this to denote that. So AEC is congruent to DEB. So where's DB? So this one over here. So we're saying that these two are congruent. So I'll go ahead and try and denote that in a friendly way. Okay. We also know that BE is congruent to CE. So segment BE is congruent to CE. So those are segments. And then we know we're given that angle ABE. So ABE, so the one down here, is congruent to triangle DCE. DCE, so that's this over here. I'm going to use 2 tick marks to denote that. Okay. Alright, nice. So what are we trying to prove? We want to prove that segment AB is congruent to segment CD. I'm going to go ahead and use a purple pen to show that, or to, mark that, indicate that. So where's AB? That's this guy. I want to show that this one is congruent to CD over here. Okay. Alright, so again, when we start off a proof in geometry, we kind of want to figure out or determine what the endpoint is and how to get there. So we're going to kind of work backwards. So if we want to show that segment AB is congruent to segment CD, it would first of all be nice that triangle ECD is congruent to triangle EBA. It'd be nice for that to be true. We don't know that yet. But if we could show that that's true, then we can use CPCTC to show that CD is congruent to AB. So let's see if we can find a way of doing that. Is there any way that we could demonstrate that those two triangles are congruent? And I see something interesting going on here. If you're looking at this, we can make an argument to show that this angle right here, which is CED, is congruent to the angle on this side, which is AEB. Because you see how they overlap in this middle region? So this big one is congruent to this other big one, but they both have this overlapping one right here. So you can subtract it from both of them, and you'll arrive at the statement that AEB is congruent to CED. And once we know that, then we can use angle side angle, because we already know that EC is congruent to EB, and we also know that ECD is congruent to ABE. So using that information, we can conclude that triangle ECD is congruent to triangle EBA, and then that implies that segment AB is congruent to segment CD, using CPCTC. So that's kind of the outline, the general strategy here. So you want to kind of see the logical relationships, right, between all these different components. So let's go ahead and get started with this. Let's put the statements here, and then our justifications over here. And then we have the given. So I'm going to go ahead and just put a squiggly line for a given because you know what to do there. So, and then reasons. I'm going to write given for the first part. Okay. So the first thing that we want to pay attention to is, again, we want to show that angle AEB is congruent to CED. That's kind of our first step here. We want to show that. So to do that, we can go ahead and use the angle addition postulate. So let's go ahead and do that. So I'm going to say measure of angle AEB plus measure of angle BEC is equal to measure of angle AEC. And I'm going to name them. I'm going to use a convention that they're using in the given statements there, so I'm going to name the angles accordingly. All right, so we've got that. And then conversely, we have that measure of angle. We call this one AEB, so I'll call this one DEC. So measure of angle DEC plus measure of angle, that one was DEC. All right, so CEB. Measure of angle CEB is equal to measure of angle DEB. So it would be DEB. Yes, that's correct. And this is just the angle addition postulate. So angle add pos. All right, nice. We got that. All right, so what's next? Now, we can go ahead and use the substitution property. But first, we need to show that the two angles are equal to each other. So let's do that. So we're going to say measure of angle AEC is equal to measure of angle DEB. And we know that by the definition of congruent angles. Okay, so we've got that. Now we can go ahead and use the substitution property. Let's see. And one quick thing, I'm going to change the labels on this so that it's not as, because it looks confusing the way it's written here. Let me change the labels here. So you see how here it says measure of angle BEC, so it's BEC, and here it says CEB. Notice the two angles are the same. So I'm just going to go ahead and write it one way, so that this one will change. I'll put this on a CEB. So just kind of changing the labels a bit just so that they're kind of named consistently to avoid any confusion. Alright, so we have that. This means that we can go ahead and write measure of angle AEB plus measure of angle CEB is equal to measure of angle DEC plus measure of angle CEB. This is the substitution property. Now that we have that, we can go ahead and use the reflexive property to state that measure of angle CEB is equal to measure of angle CEB. This is reflexive. Then we can use the subtraction property, and we get at the statement measure of angle AEB is equal to measure of angle CEB. Wait, so did I write that right? Oh, sorry, measure of angle DEC, that's what I meant to say. Alright, so that one was subtraction property. So now that we have that, we can go ahead and use the definition of congruence to conclude that angle AEB is congruent to angle DEC. So def of congruence, congruent angles. Okay. Now that we have that, we already know that BE is congruent to CE, and angle ABE is congruent to angle DCE. So we can go ahead and jump straight to triangle AEB. Triangle AEB is congruent to triangle DEC. So this statement comes from, we use the angle side angle. Okay, so we got that. And then finally, we get that segment AB is congruent to segment CD. And this comes straight from the CPCTC. So corresponding parts of congruent triangles are congruent. CPCTC, that's what that means. And then you're finished. Oh, and by the way, this says this 2x plus 5, this is from something else, so just ignore that. That doesn't mean anything here. Okay.